In this lesson, we're going to be learning how to write a quadratic in vertex form. And we're going to learn this thing called completing the squares. That's why I put both of these titles, because we're not quite going to talk about what they look like on a graph yet, but it's the same process. So I wanted to make sure you've seen both terms. So before we get into completing the square, I want to do something that we've seen before. So we're going to do a little bit of a review. So can you write review for me? Hopefully, if you had time to write down your title, you can always pause the video if you need to. Can you put for the directions, this is example A, can you rewrite in standard form? Rewrite in standard form. So before we get into completing the square, we're going to work on some stuff that we've already done before. So can you write the example number 1 and write x plus 3 and on the outside squared? We want to write this in standard form, which means we want to get rid of the parentheses. When we see this x plus 3 squared, this is not distributing the square. It's the same as x plus 3 times x plus 3. So what we're going to do here is, in order to multiply this and write it in standard form, we're going to do the boxes. So I'm going to make my 2 by 2 boxes. This is going to help us to go backwards eventually. So remember, we're going to have x plus 3 on the side, and then x plus 3 at the top. So we're multiplying. This is what we did before we factored. So to rewrite this in standard form, x times x is x squared. X times a positive 3 is positive 3x. Positive 3 times x is positive 3x. And 3 times 3 is positive 9. If we rewrite this, we have our answer of x squared. We can combine these middle terms. So we have plus 6x. And then we have plus 9. I'm going to have you notice something in a second after we do example number 2. So for example number 2, can you write x minus 5 in parentheses and then square it? And again, if we're going to write it in standard form, which looks like this is the same as x minus 5 times x minus 5. So what we're going to do is we're going to do boxes again and multiply. So we're going to have 2 by 2 boxes. And we're going to have x minus 5 on the side and x minus 5 at the top. So notice same binomials on the side and on the top. So x times x is x squared. This box becomes minus 5x. This box becomes minus 5x. And then negative 5 times negative 5 is positive 25. All right, if we combine like terms and rewrite in standard form, we can combine those two. We get x squared. These two, negative 5 minus 5 is negative 10, so negative 10x, and then plus 25. Now I want us to notice something. If we were to go backwards, if I was to give you this polynomial and said to write it as factors, to go back to here, I want you to notice that half of 6 is 3, and 3 times 3 is 9. So notice we can change that to x plus 3 times x plus 3, which just means this squared. Let's look at this one. If I divide this negative 10 by 2, I get negative 5. And does negative 5 squared give me 25? Yep. So that means I can write it as x minus 5 times x minus 5. So basically, all I'm doing to go backwards is taking half of this middle term and just making sure I can square it at the end. So now we're going to practice going backwards a little bit. So can you write, for example, B, rewrite as perfect squares. Rewrite as perfect squares. So this time it's like we're factoring. This is going to help for later. Rewrite as perfect squares. So we're going to do 4 examples here. So for example 1, move this up a little bit. Example 1, can you write x squared plus 12x plus 36? Okay, so normally what we would do is 2 sets of parentheses. We're going to do this the long way. X and x go in the front. Then what we would do is find factors of 36 that add up to 12. So I'm going to take my calculator, get rid of all my old junk, and I'm going to do 36 divided by x. Go to my table, start with 1. Factors of 36 that add up to 12 would be 6 and 6. And because we're adding, they're the same sign. I don't want to do that anymore. That took too much time, so I want you to notice something. If I take my 12 and divide it by 2, I get 6. If I can take that 6 and square it and get the same number, then I can write it as x plus 6 squared. So again, if it's a perfect square, half of this squaring it would give you 36. So half of 12 was 6, and if we square it 36, it worked, so we're going to write it as a perfect square. Let's try another one. This is number 2. Can you write x squared minus 12x plus 36? Now let's see if we can write it as a perfect square. So I'm going to take this middle term and divide it in half. Negative 2 divided by 2 is negative 6. If I square negative 6, negative 6 times negative 6 is 36. Is that my last term? Yep. So that means I can write it as a perfect square. So here's the long way. We have x and x, 6 and 6, minus, minus. But now my shortcut is, since I took half of this and squared it and I got the last term, I'm just going to put x in the front and this divided by 2 number in the middle and square it. Confusing? We're going to do the next one without all this work. This is number 3. Can you write x squared plus 20x plus 100? So let's see if it's a perfect square. I'm going to take this number in the middle, this 20, and divide it by 2. That gives me 10. If I square that 10, 10 squared, that's 100. And that's what I see right here. So that means this is a perfect square. So here's how I can write this. 2 sets of parentheses, or 1 set of parentheses, put a little square on the outside. So we have x in the front, and this is a positive 10, so plus 10 here. If you can't do this quickly, you can just write your 2 sets of parentheses. You don't have to show this. X and x. Factors of 10 that add up to 20 would be 10 and 10, and plus plus. So this is your perfect square. So only if you notice that you take half of this and square it at the end. If it looks like that, is a perfect square. One more, example 4. Can you write x squared plus 8x plus 3? So let's see if it works. I'm going to take this 8 and divide it by 2. So 8 divided by 2, that's 4. If I square the 4, does that give me 3? No, it gives me 16, which is not 3, so I cannot factor this. So can you write cannot factor? Not factor. There are no factors of 3 that add up to 8, and it's not a perfect square because if it was, you would have plus 16 at the end and not plus 3. I'm going to show you right now the whole point of this. We are going to take a quadratic and we're going to make it look like one of these in the beginning, but we're going to have something at the end. So I'm going to show you those steps. So I'm going to switch my paper and give you some steps as we're doing an example. So can you write steps for me? Actually, can you write, maybe write to write a quadratic expression, to write a quadratic expression to vertex form, in vertex form, you can complete the square. You can complete the square. And I'll show you what I mean by that. So on the top, if you want to write this, you don't have to, but our standard form looks like this, ax squared plus bx plus c. We're going to write it in vertex form, which is going to look like this, a parentheses x minus h squared plus k. Kind of weird looking, but we're going to have this perfect square in the middle with something at the end. So I'm going to show you what that looks like. So here's our steps. And what I'm going to do is we're going to do that example 4 that we couldn't do in the first place. We're going to do it at the end. So can you write x squared plus 8x plus 3? This doesn't seem as confusing as it's starting off to be, I promise. So we're going to use this example as we're doing our steps, and there are 4 of them. So here's step 1. Find half of b. What do I mean by that? Well, this number in the front, this imaginary 1 is your a. This 8 in the middle is your b. And this number at the end is your c. So your b value is 8. So the first thing we're going to do is take half of b, which is 8. So 8 divided by 2. That's what we were kind of doing on the front. 8 divided by 2 is 4. So that's step 1. Step 2. If you notice what we were also doing to see if it was a perfect square, we took half of the number, we would square it to see if this number at the end was a perfect square. So here's what we're going to do. Step 2, square that value. Square that value. So we're going to take this 4 and square it. So 4 squared. Well, 4 times 4, that's 16. So step 1 was half of b, half of our middle number. Then we squared it. Here's step 3. Add and subtract that value in the expression. Let me show you what that looks like. So add or subtract that value in the expression. So I'm going to take this 16 and add and subtract it. So I'm going to bring down my first 2 terms. So we have x squared plus 8x. I'm bringing down the original. Now I'm going to insert in that square. So I'm going to add 16 and subtract 16. And don't forget there was a plus 3 at the end, so I put that at the end. So I just added and subtracted 16. The reason why, if I am adding 16 and subtracting 16, notice the value is 0. It doesn't change the value of our expression. If we do that, now we have our perfect square here. So here's step 4. Rewrite as a perfect square. Rewrite as a perfect square. I'll show you what that looks like. So what we're going to do is we're going to take the first 3 terms and we're going to make a perfect square out of it like we were doing on the front of our notes. So remember, half of 8 was 4, 4 squared was 16. So our perfect square is going to be half of this middle number, which is 4. So we're going to have x plus 4 in our parentheses squared. Then we're going to combine these 2 numbers. So negative 16 plus 3 gives us negative 13. There is our answer in vertex form. Why do we need to do this? You're going to see in a minute why this is helpful on a graph. But right now we're just practicing writing an expression like this as a perfect square, which is called completing the square. So we're going to do 4 examples. So here's example, I think we're on C. So here's example C. This will go a little bit quicker since we're not writing the steps. Can you write x squared minus 4x plus 15? All right, so we're going to write this like this, completing the square. So step 1 is to find half of b. Remember right here, this middle term is your b. So we're going to take half of negative 4. So negative 4 divided by 2 is negative 2. Step 2 is to square that value. So we're going to take negative 2 and square it. Notice I put parentheses around it. Well, negative 2 times negative 2 is 4. Step 3, we're going to add and subtract this number in our expression. So we're going to take the first 2 terms, x squared minus 4x, and we're going to add and subtract this number. So we're going to add 4 and subtract 4. And then don't forget to bring down the plus 15 at the end. So you always have to add first. Step 4, we're going to rewrite it as a perfect square. So this right in the front is going to become a perfect square. So this, remember, we take half of this middle number. So I'm going to bring down my x and square. Half of negative 4 is negative 2. So I have x minus 2 inside. Notice it's the original number. Then I'm going to combine these two terms. Negative 4 plus 15 is positive 11. If you're not understanding where this is coming from to get this, let me show you on the side, and you don't have to do this. If I was to factor this the long way, x and x, factors of 4 that add up to 4 would be 2 and 2. And because we're adding, we need the same sign, so they both need to be negatives. If you notice, this is the same thing twice, so this can be written as x minus 2 with a squared on the outside. So that's where this is coming from. So let's try this again. Example D. Can you write x squared minus 2x minus 15? So we're going to do these steps. So step 1, find half of b. Your b is your number attached to the x. So we're going to take half of negative 2. So negative 2 divided by 2. That gives us negative 1. Step 2, we're going to square that value. So we're going to take negative 1 in parentheses and square it. Well, negative 1 times negative 1 is positive 1. Step 3, we're going to add and subtract this number in our expression. So we bring down the first two terms, so x squared minus 2x. And we are going to add and subtract 1 to make it a perfect square in the beginning. And don't forget your minus 15 at the end. Step 4 is to take this and make it a perfect square. So this, since it's a perfect square, since we added and subtracted the 1, it's going to look like this. We bring down the x. Half of negative 2 is negative 1, so we have a minus 1 inside. And we square it. And again, it would be something like this. If we combine these two terms, negative 1 minus 15 is negative 16. So there's your answer in vertex form, which means completing the square. 2 more examples, and I think you'll get the idea. Here's example E. Feel free to pause the video and try it on your own. So let me take this off. Example E. Can you write x squared plus 20x minus 40? So remember, step 1, you take half of b. Your b value is the number attached to the letter x. So we're going to take 20 and divide it by 2. 20 divided by 2 is 10. Step 2 is to square it. So we're going to take 10 and square it. I don't need parentheses if it's a positive. 10 times 10 is 100. What are we going to do with the 100? Step 3, we're going to add and subtract that value. So we're going to bring down the original two terms, x squared plus 20x. In front of this, to make it a perfect square, we're going to add 100, but don't forget to subtract 100. And then we're going to bring down the minus 40 that it originally was. Remember, we can add these in because it just cancels out if we were to rewrite it. Step 4 is to make this a perfect square. So right here is a perfect square. This is what it looks like. I put the x in the front. Half of 20 is positive 10, so plus 10 goes inside, and we square it. Then we take this last set and we combine them. Negative 100 minus 40 is minus 140. So there is your vertex form by completing the square. One more, example F. And again, pause the video if you'd like to try it on your own. X squared minus 10x plus 27. All right, so I'm going to go ahead. Step 1, take half of b. Well, my b is my negative 10. So I'm going to do negative 10 divided by 2. Negative 10 divided by 2 is negative 5. What do we do for step 2? We square it. So we're going to take negative 5 and square it. Negative 5 squared, that would be 25. Step 3, we're going to add and subtract this number in our original expression. So I'm going to bring down the first two terms, x squared minus 10x. I'm going to add 25 and subtract 25. But don't forget to add the 27. So now what we're going to do, step 3, is we're going to rewrite it as a perfect square. So I'm going to take these first three terms, since we added 25, it's a perfect square now. So we're going to put x in the front. Half of negative 10 is negative 5, so that goes with the x, so minus 5. Don't forget your squared. And now we're going to combine these. Negative 25 plus 27, that's a positive 2. So there's your answer. The reason why I showed you this, when we did the zero product property in the last lesson, I'll just give you an example. You don't have to draw this. If we had this right here, when we were finding our zeros, let's say, when we were solving, when we had a quadratic equation, those zeros would be where it would touch the x-axis. So those would be our solutions. This right here would be our vertex of our parabola. So for instance, I would have a parabola like this, and it would be my vertex somewhere down here. This, if you want to know, our vertex, that would be this lowest point or highest point, would be the opposite of the first, which you don't have to write, would be 5, and then 2. So if I was graphing it, 5, 2 would be over here, and my parabola would be up this way. So this is what vertex 1 will help us with in the next few lessons. Please remember to fill in the notes and send a picture to get credit in Canvas.